Dr. Vijay Lakshmi is working as a professor in the Department of ECE, Anna University, Chennai. She has more than 17 years of experience in teaching. She has published more than 90 papers in international and national journals and conferences. She has organized more than 10 workshops and has attended more than 40 workshops and seminars. She has guided more than 100 projects in both UG and PG level. She is supervising 14 research scholars. She has established an AICTE-sponsored MODROB project for VLSI Lab. She has an endowment award for the top rank holder in PG degree and has 4 cash awards for producing 10% of result in Anna University curriculum. She is a life member in various professional bodies like ISTE and IETE. She has specialized in mobile communication, microprocessor and microcontroller, digital system, computer networking, and neural networks.
Welcome to UGC lecture series, BSc Electronics Honors, Electronics Practicals 3, MATLAB Programming. In today's episode, we will discuss about Fourier series representation of continuous time signals. The Fourier series, it is represented with the 3 constants which are A0, An and Bn. So, how to derive these 3 constants from the expression and how to write the MATLAB programming will be discussed on today's episode. Fourier series of periodic continuous time signals. The another one, complex exponential Fourier series. The complex exponential Fourier series representation of periodic signal x of t with the fundamental period t0, which can be given by, that is, x of t equal to e power j omega naught t. The t can be replaced with t plus t0. So, here the Fourier coefficients is represented with Ck. Ck is the complex Fourier coefficients which can be given by Ck equal to 1 by t0 integral of lower limit to upper limit minus t0 to t0 x of t e power minus j omega naught t into dt. So, from this, if you want to calculate the average value, which is C0, this is the initial value or middle value between the negative limit and positive limit, which is given by C0 equal to 1 by t0, the integral of minus t0 to t0 x of t dt. So, this is the remaining coefficients. Instead of calculating ak and bk, in the complex Fourier representation, we are calculating only the Ck. The initial value instead of A0 or the average value instead of A0, here we are calculated as C0. So, when the x of t signal is real signal, then the C of minus k equal to C of k, that is the complex conjugate value is equal. So, now we will find the relation between the coefficients, which are the complex coefficients and the trigonometric coefficients. If we know, then we can easily obtain its representation, that is A0 by 2 is equal to C0, the average value. Then AK is represented as Ck plus C minus K is a conjugate of the signal. These two are the complex representation. Bk is the imaginary part of that value, that is J of Ck minus C minus K, that is conjugate of the complex signal. Suppose if you want to find what is the complex signal or complex conjugate signal in terms of the trigonometric coefficients Ak and Bk. So, for that you can obtain Ck equal to 1 by 2 Ak minus J Bk. Then C minus K equal to 1 by 2 AK plus J Bk. So, after obtaining the complex coefficients, if you want to find the modular value or the phase value of the signal, you can get the C0 equal to A0 by 2, which is the average signal. The Ck, if you find the modulus signal, then the modulus of Ck or the absolute value of Ck equal to AK square plus Bk square, that is a real square plus imaginary square, square root of AK square plus Bk square. If you want to find the phase representation of the complex coefficient, then it will represent as theta k equal to tan inverse of imaginary coefficient by real coefficient, which is bk by ak. Consider another example like this wave, right? One of the square wave which is periodic representation, right? So, this is 20, the another signal is 30, but we are considering the first period which is t equal to 10, right? One on and off period like that. So, for that wave, suppose if you are calculating t equal to 10, then what is omega naught value? Omega naught is equal to 2 pi by t, which is 2 pi by 10. So, it is simplified as pi by 5. So, now I will write the a naught value. So, a naught is equal to 1 by t integral 0 to, or you write it as 0 to t, right, then f of t into dt. So, the 1 by t value was 1 by 10, the integral is 0 to 10 f of t into dt. If you have the continuous signal for 0 to 10 as f of t, you can put it as 1, but here we have a two kind of representation, right? One is the plus 1, another one is minus 1. So, we have to split the integral. So, 1 by 10, 0 to 5 value is 1 into dt plus 5 to 10 minus 1 into dt. So, 1 by 10, after integrating you get the t value 0, 5 plus this one is minus t, right, 5 and 10. Now, substitute the limit 1 by 10 of 5 minus 0 plus this 1 by 10 is common to both, right. So, minus 10 minus of minus plus 5. So, finally, what you get 1 by 10 of 5, this one is minus 5. So, you get the value was 0, a naught value was 0. Now, calculate the value a n is equal to 2 by t integral of 0 to t f of t into cos omega n t into dt. So, which is 2 by 10, 0 to 10 f of t into omega value was cos pi by 5, right. What we get? So, pi by 5 into n into t into dt. So, 2 by 10, split the integral 0 to 5, 1 into cos pi n t by 5 into dt plus 5 to 10 minus 1 into cos pi n t by 5 into dt. So, 2 by 10, the cos pi n by t value was sin pi n t by 5, then again divide by n pi by 5, integral 0 to 5 plus this is a minus, right. So, minus sin pi n t by 5 divided by pi n by 5, 5, 10. Now, take this term as common. Okay. So, if you are bring it out, then already 2 by 10 we have. So, this become 5 by pi n, right. You simplify it as 2, 2, 2. So, finally, you get 1 by pi n, right. Now, substitute the value if you are substituting the value 5 here, then what it become? So 5 cancel. So after cancelling 5, you get only n pi. So by n pi, for any pi the sign value is 0. Then after substituting the lower limit, it also 0. So this term become 0. For this term, if you are substituting 10, so 10, then it become 2, right? 2 pi. So any terms of sin pi is 0, then here after substituting 5 also you get the 0. So the sin term become 0. Now derive the third coefficient, which is Bn. Bn is equal to 2 by t, 0 to t, f of t sin omega n t into dt. Now take the value 2 by 10, then split the integral 0 to 5, this value is 1. So sin omega n t into dt plus 5 to 10 minus 1. So minus sin omega n t into dt. So if you want to substitute the omega value, which is pi by 5, it reduced as 1 by 5, then the integral of sine become cosine, right? So cos pi n t by 5 divided by pi n by 5. Then limit is 0 to 5 plus, already we have minus, right? So minus cos pi n t 5 by pi n by 5. Limit is 5 and 10. Substitute the limit, or you take this term as common. Okay. So how do you get it as 1 by 5 into 5 by pi n, right? 5 cancel. So finally you get it as 1 by pi n. Okay. So now you substitute the value 5 here, then you get 5 cancel, right? So cos pi n. Cos pi n is, what is the value? It may be plus 1 or minus 1. So I will write it as minus 1 power n. Then cos 0 value, for the lower limit, that value is 1, right? This is for first case. In the second case, if I put the value 10, the upper limit, so what it become? It's a 2 pi. So cos 2 pi value was 1. So cos 2 pi value is 1. Already we have a minus 1. So minus 1. For lower limit, I have to take it as minus. If I substitute the value as 5 cancel, then you get it as a pi n. So pi n become, based on the n value, it may be plus 1 or minus 1. So it can written as minus 1 power n. Okay. So after simplifying, what you get? So 2 minus 2 power minus 1 by n pi. So this is a Bn value. So from that, what we are saying, suppose n equal to odd. So n equal to odd means what did it become? This value become minus 1. So minus of minus, this become plus. So you can written as 4 by n pi. If it is even, then this become plus 1. So you get it as 0. So for odd, you get 4 by n pi. For odd value, you get 4 by n pi. For even, you get it, the value was 0. So this is a Bn value. Bn equal to 4 pi n pi. For n equal to odd, the Bn value is 0 when n equal to even. Okay. So now we have to execute this program in MATLAB. Now I take the n equal to some constants up to 100, then the W naught is initialized as pi by 10, right? So 2 pi by 10, or simply you get, after simplifying, what we get? Pi by 5. So I will give pi by 5. then you take t value which is equal to -1 to 11 with the variation 0.01. So, f equal to zeros of 1 comma length of t. So, now write the loop for n equal to 1 to n with a variation of 2. Then now write what is the Bn value. A naught value we obtained, An value is 0, Bn value was equal to 4 divided by pi into n, right. Then f equal to f plus Bn multiplied with sine of omega naught into n into t. Then end, then plot t comma f. You can take the axis -2 to 12, then -1.5 to plus 1.5. Okay. Now save the program. Fourier series 2, execute it. So now we get the sine wave. We have assigned the capital N value as 10, right? Then we are varying the limit from 1 to capital N with a period of 2. So, the small n only we are initializing for the loop. So, by varying the n value, suppose if I give a n value as 1, execute your program, you get a single sine wave, right. If you give n equal to 3, you can identify the changes, how many changes is occur. Suppose if we are giving 10, the number of pulses you can count it, right. This is a 10, here 5 signals, here 5 signals. So, by varying the number you can obtain its coefficients. So, this is for n equal to 1000. For 500, okay. So, this is a way we are obtaining, simplifying the expression and develop the MATLAB coding to get the Fourier series representation. So, in today's episode, we have discussed about the Fourier series representation for continuous time signals. So, how to represent the continuous time signals and what are the Fourier series coefficients. Then how to obtain by the mathematical expressions and how to write the MATLAB coding as discussed on today's session. Questions. First question, how do you represent the final Fourier series representation, that is f of x? Write the relationship between the trigonometric representation and complex representation. With this, I will conclude this session. Thank you.